minus 1 minute, everyone.
Don't be shocked if we hold.
Back ground for a safe touchdown, hopefully.
They're not seeming to care about it.
Here we go, Booster what?
They're not seeming to care about it on the tech feed, but we can confirm.
And touchdown!
Good morning, afternoon, or evening, wherever you are watching this live coverage from. Welcome to the first Project Kuiper flight on a Falcon 9 rocket. We are here live just 25 minutes away from the launch. I did not get the countdown set up yet, so I will be getting that up shortly. Today we'll be covering everything of Project Kuiper's flight for today and all the coverage. I don't know what will happen to SpaceX's coverage, if they will end the coverage or not. We will see. Glad that you're joining us here today for this Project Kuiper launch. This time launched by a Falcon 9 rocket, which I think is pretty interesting because it's literally their competitor in Starlink satellites. So pretty cool. But still, so I'm just checking some stuff here, countdown, etc. So just give me a second. I'll even get the SpaceX version countdown because I made it. Does it even... Oh, did I accidentally put on the Starlink one? Oh geez. Don't tell me I did. Oh no, it's not a Starlink. Oh no. Oh no. Okay, whoa, we're 24 minutes away and I forgot the text on the bottom. So what we're gonna do, please hang on. We're gonna just do Project Kuiper. I'm gonna guess that is the name of the flight. Where does that get put? Oh, it's here. It's not the real GUI, guys, don't worry about it. It's just I made it real quick. I'll just use the normal countdown, I guess. This one is actually very stupid. Okay, let's get the normal countdown over here. Because people might think this is the real coverage. It isn't. Okay. Looks like we're now less than T plus 23 minutes, 3 minutes away from the launch here. So yeah, about Project Kuiper. It's an interesting vehicle or satellite. Competitors with Starlink. Fun fact. So I've said that earlier this stream as well. So yeah, basically Project Kuiper, if you didn't know, it's a new internet plan from Amazon. Pretty interesting. Amazon is a company that does products, not satellites, but I guess they're doing satellites now, which is pretty cool. They're putting small satellites into space to help more people get internet. Just saying it easy for you, so y'all understand. Especially in places where it's hard to get good connection. So they're like, okay. Yeah. So the goal is to help people who don't have like good Wi-Fi internet, stuff like that. Because like they're in small towns or faraway places where it cannot be accessible. And then Amazon helps, the Project Kuiper project helps with that. So people have Wi-Fi internet to watch videos, talk to friends, go to school, work from home. That's basically, in a nutshell, that. I guess it is 8 in the morning. It's 8 in the morning, and I might have just woke up some people because I screamed something. Anyway, about that. Let's see. Project Kuiper, Journey to Launch. We have a few videos from Project Kuiper themselves. 7th of April 2025. 2025. Let's see, what is this? Is it supposed to not have like audio? It's supposed to have audio. Okay, hold on, coverage break. I just have to fix the audio. That's somehow not. Oh, I understand. It was on Steam streaming speakers. What does that even mean? Who added that? Okay, well, never mind. Look at that, the 20-minute vent is now started. Good news. That means we are going up, by the looks of it. Wow. Let me actually get you a video of Project Kuiper, because of course very important so to know about Project Kuiper's project stuff, things, etc. So I think it's a pretty cool idea to watch a video of that now. So if you just have a minute, because I have some things that are on that might disturb that, so I will be turning them off right now. If it works, there it is. It does. Okay, let me just revert it to 8. Maybe that's better. Okay, that's green. Sorry, like I've never used this browser before on OBS. Like with browser, I mean like the reverse, because I have like 2 browsers I do streaming on, and I haven't used one in like months. So pretty weird to. Okay, we got it. And yes, I just woke up like 40 minutes ago, with like 6 hours of sleep. So I'm barely hanging here, just doing this for y'all. But doesn't matter, because this channel is worth it. So let's watch a video of Project Kuiper's Journey to Launch.
It all starts with a countdown. But a countdown to what exactly? 6 years ago, we took on a journey to build the most advanced and the most modern communication system in the world. There are almost 3 billion people that don't have high-speed connectivity. Imagine if they had the ability to be connected just like you and I do, what they could do, what contributions they could make.
This mission is ambitious for a truly worthy cause. It's going to impact communities that cannot be reached with fiber, traditional communications. The solution really has to be from space.
You can think of Project Kuiper as a 3-part system: the satellite constellation, the customer terminal, and just as critically, the ground network and software that ultimately deliver connectivity. We have set out to design the most advanced satellite network ever built, and we have created the whole thing in-house at Amazon. You need just about every technology area to contribute to build the satellite The propulsion system, the solar arrays, the silicon, the phased array antennas, the optical inter-satellite links.
The team has to be innovative, agile, resilient as we're moving very, very fast. Building, testing, developing in-house has been an extraordinary ingredient.
When we first proposed Project Kuiper internally, one of the first questions was, can you produce an affordable customer terminal? We knew that was going to be the linchpin of our system.
The big breakthrough for us was combining transmit and receive antennas into a single aperture. No one had ever done this in the Ka band. That let us pack a ton of performance into a really compact, really low-cost design. We're going to build tens of millions of these antennas, and we are well on our way. The design is done. We're now in the factory manufacturing it.
We talk about the satellites in constellation, but Kuiper is a satellite constellation being operated as a network across hundreds of ground gateway terminals.
Our ground network is spread out all over the world, and each site connects back to AWS. We already have a bunch of these sites installed everywhere from Australia to Germany, and more of them are coming online every month.
There's a big difference between launching 2 satellites and launching 3,000 satellites.
The past couple of years, my team has really been focused on how to achieve scale. Our own dedicated payload processing facility gives us the ability to control our own destiny. We've got the capacity to integrate up to 5 satellites per day and launch 3 simultaneous campaigns. Heavy lift rockets have higher performance, so we can take more satellites to orbit on any given launch. All of our heavy lift launch partners have had a successful first flight, so that's been a pretty exciting thing for us to see because we made those investments years in advance.
All of the pieces have come together to support that first launch, and the next one, and the one after that. It might not all go perfectly, but we have an incredible commitment to this project and an incredible team committed to its mission. All roads lead here, a countdown to launch. And with more than 80 missions planned, we're just getting started.
Beautiful video there, seeing Project Kuiper and their stuff there. Amazing to see it, amazing. So the SpaceX broadcast will now be beginning here. So let's actually go and switch to them shortly. Well, should we switch? We actually get, you might get a jump scares. Okay, you didn't. Perfect. Why is there no audio? Oh, some stuff to say. I'm focusing on the SpaceX broadcast, which is now started. Okay, so 12 minutes 25 seconds to go until the launch here of the Project Kuiper's second flight, I believe, or third flight. I think already was. Now I forgot again. Third flight, yes. I didn't even stream the first and second flight. The first flight was at midnight, I think, and the second flight was at school. So I do not understand how I'm having a life doing these things at once. That's just to say. Anyway, now that we have holidays, we can rock streaming, go full on streaming here while I'm having my holidays, because Saturday, if there is no launch, well, there is a launch, but in the evening. Saturday, I hope there is no launch because I will be gone for the entire day. I'll be home around the evening, still to stream the launch on my phone from that TSDG test flight, I believe. That is, I don't know if it's the 19th or the 26th. Oh yeah, and Crew 11 will also be fully streamed. So that will be enjoyable. And it seems like the SpaceX broadcast has started here. So yes. Okay, let's actually listen into the SpaceX broadcast now.
Today's mission is named KF-01 for the first Falcon 9 launch for Amazon's Project Kuiper. Project Kuiper is Amazon's low Earth orbit satellite constellation, which will provide fast, reliable internet to customers and communities around the world. This will be the third launch of Project Kuiper satellites this year, and will add another 24 satellites to its constellation. Today's mission marks our first out of 3 Kuiper missions. At T-minus 9 minutes and 30 seconds, everything is looking good for an on-time liftoff, and the range is ready to support. And just a quick note, at our customer's request, we will be ending live coverage of the mission just after the first stage booster landing.
What?
As far as weather is concerned, we've been keeping an eye on our launch commit criteria all night, and everything so far seems to be working in our favor. If for any reason we are unable to launch tonight, a backup opportunity is available tomorrow at 1:57 a.m. Eastern Time. And with that, let's take a moment to learn a bit more about the vehicle supporting today's mission. That's Falcon 9 on your screen. It's a 2-stage rocket that is 229 feet tall and is getting ready for liftoff in just under 9 minutes. At launch, it produces more than 1.7 million pounds of thrust, which is enough to lift more than its own weight. The bottom section is the first stage, or booster, powered by 9 Merlin engines. They'll burn for the first couple of minutes, carrying Falcon 9 through the thickest layers of Earth's atmosphere. But it's not just going up. Early in flight, Falcon 9 performs a gravity turn, a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. Because getting to orbit isn't just about going straight up, it's about accelerating so fast that it never lands. And that's what achieving orbital velocity is. Once the first stage completes its portion of the mission, it shuts down and separates. A staged rocket like Falcon 9 sheds the booster, so stage 2 and the payload can keep climbing faster and more efficiently. After stage separation, today's booster will land on our drone ship, a shortfall of Gravitas, which is currently stationed in the Atlantic Ocean. And this particular booster will be returning to Earth for its first time. The second stage will take over from there, powered by a single Merlin vacuum engine, also known as the MVAC. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space. And topping it all off is the payload fairing, a 17-foot wide carbon composite shell that protects the satellite during the uphill trip through the atmosphere. About 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. Now, both of these fairing halves have seen multiple flights. One is flying for its 28th time today, and the other is flying for its 27th. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again. So much of what makes Falcon 9 remarkable happens in flight. The those stages separating, the first stage landing itself on a drone ship in the middle of the ocean, the fairing parachuting back, all to get ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing: escape gravity. And that is the first step in building our multiplanetary future. At T-minus 6 minutes and 23 seconds, Falcon 9 is tracking no issues, and our payload is looking healthy. Falcon 9 has been loading propellant since T-minus...
Stage 1, RP1 load is complete.
Good call out there. We've been loading propellant since T-minus 35 minutes, and we're expected to finish loading at T-minus 2 minutes. If for any reason we don't launch today, we do have a backup opportunity tomorrow at 1:57 a.m. Eastern Time. Next up in the countdown, the transporter erector, or the TE, will begin to retract away from Falcon 9. That's the large truss structure that you see standing next to the rocket. It's hinged at the base and is connected to the launch mount beneath the first stage. First, we'll see the clamp arms open around the second stage. Then the TE will begin to pivot back, slowly swinging away from the rocket. It'll reach its full recline by T-minus 3 minutes and 40 seconds. You might also hear the TE called the strongback. It's the same structure, just referred to as a different name. The TE also does... The TE also does a lot more than just lean.
Or strongback retract.
Good. So it sounds like we're going to go for strongback retract. It's going to start to lean away from the rocket now. We should be expecting those clamp arms under the second stage to start opening up. It'll take about 15 seconds for them to fully open. And there they go. Once they're out of the way, the strongback can recline away from the vehicle and give it room for liftoff. Looks like the arms are now open and the rocket is free. You can see it slowly starting to move away from the rocket now.
Strongback retract has started.
Right now, both stages are nearly fully loaded with about 1 million pounds of propellant. That includes RP1, a highly refined kerosene, and liquid oxygen, chilled to under 300 degrees below zero. Propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser propellants mean more performance out of the same tanks. The colder it is, the more mass that you can move. Before any of that propellant flows, though, the plumbing and engines are chilled down. That prevents thermal shock and boil off when the ultra-cold liquid starts moving. You might also hear that referred to as engine chill.
Stage 1, LOX load is complete.
As you just heard over the nets, there's confirmation of Stage 1 liquid oxygen loading completion. The second stage will finish up about a minute later. The tanks are also pressurized using helium. That helium is chilled too, so it stays compatible with the cryogenic plumbing. During flight, that pressurization helps force propellant into the engines as the tanks empty. At T-minus 60 seconds, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will take over. From there on out, the countdown becomes fully autonomous. Just inside of T-minus 2 seconds, and the 9 Merlin 1D engines will ignite. And once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit.
Stage 2, LOX load is complete.
And another great call out. So the first and second stages are now fully loaded with over 1 million pounds of rocket-grade kerosene fuel and liquid oxygen. You've probably noticed those white clouds that are venting from the rocket. That's not smoke, it's actually condensation. As the liquid oxygen warms slightly inside the tanks, some of it boils off. That gas is then vented to manage the pressure. When the vented oxygen hits the warm, humid Florida air, it instantly condenses into those clouds. It's the same principle as your breath on a cold morning, just on a much, much bigger scale. As of now, the satellite remains healthy and the rocket is tracking no issues. Weather looks green and the range is clear to support our scheduled liftoff of 2:30 a.m. Eastern Time.
Falcon 9 is in startup.
At this point, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressurizing for launch. Finally, we're waiting for the final go directive from the launch director.
The launch director is go for launch.
We just heard that we're a final go. With that, Falcon 9 is fully fueled in startup and heading into the final seconds before launch. Let's listen in to the countdown.
30 seconds. 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignitions. Engines full power. And liftoff. Go Falcon, go Kuiper. The vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. In just a few seconds, we'll throttle the engines down in preparation for max Q, the period of maximum aerodynamic pressure. To help go from vertical to horizontal, the first stage performed a pitch kick just after liftoff, about 10 seconds into flight, which is a maneuver known as a gravity turn. The engines gimbal a small amount, and that slowly turns the first stage from going straight up
Falcon 9 is supersonic.
to going horizontal with the help of gravity. And eventually, will be roughly horizontal to Earth as we achieve orbit.
Max Q.
And there's the call out for max Q. Continuing on the timeline, everything's looking good. The rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. You can track our progress to orbit by watching the left corner of your display. That's going to show us the first stage velocity and altitude. Now we have several events coming up in quick succession, and we should hear all of these called out by Mission Control, starting with main engine cutoff, or MECO, then stage separation, SES-1, and fairing separation. MECO is where we shut down all 9 M1D engines on the first stage. Then stage separation is when the first and second stages of Falcon separate from one another. And second engine start 1, or SES-1, is when we'll light the MVEC engine on the second stage for the first time. Then less than a minute later, the fairing will then jettison from the second stage, as it's no longer needed to protect the payload once we're in space. So let's keep an eye out for these events happening back to back, all coming up in about 10 seconds from now.
MECO.
Stage separation confirmed.
Stage 2 startup.
Good series of call-outs back to back, which again were MECO, stage separation. Coming up next will be fairing separation in about 30 seconds from now. As mentioned earlier, we will be attempting to retrieve these fairing halves once they fall back to Earth. They'll be taken back to shore by our ocean recovery vessel, Doug, once they fall back down to Earth. And we should be hearing that call out for fairing separation in just about 10 seconds from now.
Fairing separation confirmed.
Here's a good call out for fairing separation.
All right, just coming back here. Beautiful launch as well from the cams here everywhere. It was insane. So cool to see the launch from multiple perspectives. Because I'm just seeing the NSF streaming and our cams. It's just insane. Beautiful to see. So we're not getting any stage 2 views, although we got one at the beginning. We're now not getting it anymore, I guess. But holy crap, I just witnessed. That was so cool to see. It is even now at the moment doing it looks like a jellyfish kind of thing. Maybe it's because of the moon. I don't know. It's just, you can slightly see it. Well, not anymore, but you could slightly. You saw it for a second and then you couldn't. It's just, it's so weird. Anyway, successful liftoff though. Wow, that's gonna be cool shots for the team. That is interesting. I'm gonna have to see. You're gonna have to see these shots later. This is absolutely insane. Let's go back to the SpaceX coverage, by the way.
We're about 20 seconds away from the beginning of the entry burn. If you like, you can check out the telemetry on the bottom of your screen, where you can watch the graphics light up as the engines do.
Stage 1 FTS has safed.
Stage 1 entry burn startup.
Here's a call out for entry burn startup on the Falcon 9's first stage. The burn is set to last about 25 seconds and again is slowing down the vehicle in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And there's the call out for entry burn shutdown, the completion of the Falcon 9 first stage's entry burn. Coming up next will be the first stage's landing burn.
Stage 2 FTS has safed.
Which is going to start a little over a minute from now. The Merlins on the Falcon first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. The single MVAC engine on the second stage has a much wider nozzle and is optimized to operate in space, producing over 220,000 pounds of thrust in vacuum. Coming up next, we'll start our landing burn on the first stage, followed quickly by the MVAC engine shutdown on the second stage. Coming up next, in about 40 seconds, we'll have the start of that landing burn of the first stage. The landing burn...
Stage 1 transonic.
The landing burn is the final burn of the Falcon 9 booster, used to reduce the remaining speed of the vehicle for a gentle and precise landing on our drone ship, a shortfall of gravitas. And we should be hearing that call out for the first stage landing burn in just a few minutes.
Stage 2 is in terminal guidance. Stage 1 landing burn.
Good call out for landing burn start on the Falcon 9 first stage. And this is the final burn that this booster will see before touching down on a shortfall of gravitas.
Stage 1, landing leg deploy. Stage 1, landing confirmed.
There's the call out for a successful landing of our Falcon 9 rocket. This was the first launch and landing for this first stage.
Nominal orbit insertion.
Good call out too. A great way to cap off this early morning mission. As we mentioned at the top of the show, at our customer's request, we will be ending our live coverage now that the booster has landed. So let's wrap up tonight's broadcast. All of us here at SpaceX want to thank our customer, Amazon. We also want to thank the Eastern Range and Federal Aviation Administration for supporting this mission. If you're interested in more launch coverage, be sure to check out spacex.com/launches for the most up-to-date information. And remember to follow at SpaceX on X. Thank you for tuning in, and we'll see you again soon.
Okay, I now want to come with the replay shots of the launch. So, a beautiful launch occurred. And I'm now going to show you the replay shots before we conclude our coverage as well here. This is a replay shot from one of the cameras here. This is awesome. I think this is just beautiful to see, because look at that. Alright, so that's gonna conclude our coverage. We want to thank you for watching now, and we will see you again probably in a few days, because today's launch of Eris is cancelled. So we'll see you later.